Hey guys, Dr. Brown here, and tonight, by special request, we're going to work on the Pythagorean Identities and look at where some of these formulations come from, and we're going to use the unit circle to do that. Now, before I jump into this, I met a gentleman. His last name started with Howe. He had a long last name. But the gentleman, he was born the same year as my mother, 1934. So he's 90 years old, same as my mom. My dad's 93, so fortunately they're still with us. But this guy was in great shape, sharp mentally, but he was a lifelong learner. Now that's something everyone can adhere to his model. So Mr. Howe, he reads a lot, he studies a lot, he loves math. So we had a great time together hanging out. He critiqued the videos that are out there, and he asked some very good questions. So let's use Mr. Howe's model to study and learn and read and be better tomorrow than today at any age. Okay? So kudos to Mr. Howe. So Mr. Howe, this one's for you. All right, we have sine, cosine, tangent functions. So let's just go over what they are for a moment. If we have a triangle and we have an angle theta, then sine of theta would be the opposite side divided by the hypotenuse. So opposite divided by hypotenuse, in this case y divided by r. Cosine would be the adjacent divided by hypotenuse, so adjacent would be x divided by r. Tangent then would be the opposite divided by the adjacent, which is y over x in the case of this triangle. Now, what does that mean with a unit circle? And how can we use these things to benefit us? So let's say we have a radius out here. Now, unit circle has a radius of 1. Okay, so now I've extended that radius up, rotated it around such that I end up with some angle theta. Okay, now what can I say about that? Well, I have the height of that, and then I have some width of it here. Okay, I'll draw it up there for the moment because it's going to be in the way. Well, if sine of this angle is the opposite over hypotenuse, recall this radius is 1. So what does this mean? Sine theta equals y over r, or if I'm solving it for that height, I multiply both sides by r times sine theta equals y. Well, if r is 1, it's 1 times sine theta equals y. So on a unit circle, this height is known as sine theta. You can similarly do the same thing with cosine. Cosine theta equals what? It equals x over r. So r cosine theta equals x. So this distance here would be cosine theta. Again, it's because a unit circle has a radius of 1. All right. Now then, what else can we do? Let's say we draw a line perpendicular to that radius. So I have a 90-degree angle right there. All right, we can now use similar triangles. Let's say we want to find this distance here. Let's just call it A, which is the side of that triangle. So I'm looking at that from the perspective of theta. Okay, so this side is to 1. Remember, this side was 1. So A is to 1. The opposite side is to the adjacent side as the opposite here, which is sine, is to the adjacent, which is cosine. So A over 1 just equals A. So A equals sine over cosine. Well, that's tangent. Of course, you may say, well, wait a minute. How do I know that? Excuse me. I think I'm getting a cough here. All right, sine, we said, was y over r. And that's divided by cosine, which we said was x over r. And you know when you divide fractions, you invert and multiply. So I have y over r times r over x. So the r's cancel. So I end up with y over x. And what is y over x? Tangent theta. So A, that length of that line here, that's tangent. And I'm running out of ink here. That is tangent theta. Okay. All right, what about the length of this side? What can we say about it? Well, if I use the Pythagorean theorem, this is the hypotenuse of my triangle. This side squared plus this side squared equals this side squared. Well, I happen to know that tangent squared plus 1 squared, which 1 squared is 1, tangent squared plus 1 is secant squared. So I know this side should come out to something secant. And let's see, let's let this side, it's my hypotenuse, right? That's my hypotenuse of that triangle here. These are my two sides. So let's see, cosine of this angle, since this is 1, cosine of theta is the adjacent side, which is 1 over the hypotenuse. We want to know this side, so let's solve it for h. The hypotenuse equals, divide both sides by cosine. What is, excuse me, what is 1 over cosine? Secant. So the length, this side, is secant theta, which worked out well because tangent squared plus 1 squared is secant squared. So each side squared added together equals the square of the hypotenuse. Okay? So far, so good. Now then, we know, let's see, this is a complementary angle here. So and that's two angles that sum together to give you 90 degrees. Well, if this is pi, this is 2 pi, half of that's pi, so from here to here is pi. If I divide pi by 2, this becomes pi over 2. Well, what is pi over 2? It's 90 degrees. So if this sum is 90, that means this angle is pi over 2 minus theta. Okay. All right, let's draw another tangent line or a line perpendicular to this radius. Okay, so that gives me another angle like that, another 90-degree angle. That's a sad looking 90-degree angle there. All right, 90 degrees. Well, the other thing we know is the sum of all the angles within a triangle is 180 degrees. So if this plus this plus this is 180, and I know that's 90, 180 minus 90 gives me 90. Well, I have pi over 2 minus theta minus 90 Well, let's not do it that way. This is going to be theta right there, because pi over 2, well, it'll be pi over 2 minus theta plus theta minus 90. Now pi over 2 is 90. So theta minus this, you know, those cancel, that cancels. So that tells me I've got 180 degrees in there. I should have said plus here. That gives me 180. Excuse me. All right. So we have 180 degrees. We know that's theta up there. So now I can look at this with respect to theta and try to solve this side also. I have A here. I still have this side is 1. And then I have a side, I have no idea what that is at the moment. All right, let's do the same as we did down here. This side is to that side. A is to 1. So the adjacent side is to the opposite side. Looking from this angle, the adjacent side is to the opposite side. As looking at this one, looking at theta also, the adjacent side, which is what? Cosine, is to the opposite side, which is sine. Okay, so A over 1 equals cosine theta divided by sine theta. Well, what is that? That's cotangent. So this is cotangent theta. What about this side? Now I could use Pythagorean theorem here. Cotangent squared plus 1 squared is, it is cosecant squared. But how can we get that a different way? All right, this is a y value, so we're going to say this length is y. So if I'm looking at it from the perspective of this angle, I'm looking at the opposite side. I could say if I'm looking at the opposite side, I'm dealing with sine here. So sine theta equals 1, which is the opposite side, divided by the hypotenuse. Keep in mind, I've got a right angle here. So that's the side, that's the side, that's my hypotenuse. So it's 1 over y. Now y then equals 1 over sine theta. What is 1 over sine theta? Cosecant theta. All right, let's write down a few identities here. We have this guy here, and I'm going to write cosine theta in here, bring this one down, because it goes to right there. Now we could say this is a side, this is a side. Sine square theta plus cosine squared theta equals 1 squared, which is 1. Sine squared plus cosine squared equals 1. We use that all the time. That's where it comes from. Okay, let's think about this triangle here. So I have a side and a hypotenuse. So I have tangent squared theta plus the 1 squared, which is 1, equals secant squared. Now many of you, if you've watched the videos, and Mr. Howell, I know he has, that sometimes we may have a radical sign where we're looking at a trig substitute, and we have tangent, under a radical is tangent squared plus 1, and we replace that with secant squared. It's under the radical. The square root of secant squared is secant. So we use these identities interchangeably a lot. Many times you may have 1 over a bunch of things and you replace that 1 with sine squared plus cosine squared because it may cancel out something. Okay, what about one more here? We have cotangent theta, which is the side. 1, that's the side. Cosecant, which is the hypotenuse. So cotangent squared theta plus 1 squared, which is 1, equals cosecant squared theta. Those are 3 identities we use consistently, and obviously cosecant squared minus 1 is cotangent, and you can do the math on those. Okay, this was for Mr. Howe. Hopefully you enjoy it, and hopefully everyone else does too. Why are we doing this? Together we're trying to build a better tomorrow and do that through math. Let's use Mr. Howe's example of studying into our golden years so that we're better tomorrow than today. That's all for now. We'll talk to you next time. Thanks.